Hey everyone, welcome back to my channel. In this video, we will learn how to store and display data using shared preference. So from this video, we will be starting our Android Kotlin Advanced series where we'll be going to cover topics like MVVM, Room Database, API, Retrofit and many more. All of these topics are kind of tricky, but don't worry, we will learn each topic with the help of project. Now come to today's video where we will understand what is shared preference. Also, just a little note that in 2023, developers prefer data store rather than shared preference, which we will cover in Jetpack Compose series. Now what is shared preference? Let's understand with a simple example. Imagine you have a small notebook like a diary in your Android phone where you can jot down some notes that you want to remember later. These notes could be things like your favorite color, a game level you reached, or whether you want the app to show music or not. Shared preference in Android is like that little notebook. It's a way for apps to store and remember small pieces of information that they can use later. Just like you open your diary to see what you wrote, app can open shared preference to see what settings or values you have saved. It's handy because even if you close the app or turn off your phone, the information you wrote down in shared preference will still be there. It's like your app's own private memory, where it can store simple things you wanted to remember, even when you're not using the app. Got it? Now let's create it. Choose Empty Views activity. Then write the name as Learn Shared Preference. And click on Finish. Let me give you a quick overview of what exactly we are going to create. So it's a very simple notes project where the user will write a note in edit text, and by clicking on Save button, it will store the note in Share Preference. And then when the user will click on Display Note button, it will display the exact note in the text view. Simple, right? You can further modify the project by maybe adding a recycler view to display multiple notes. It's all up to you. Here, I'm just going to give you a basic idea of how shared preference works. So first, let's do the prerequisite. So go to colors.xml, add the red color, whose hex code is FF3131, and done. Then go to themes.xml. Here, mention all the three parameters: color primary, color primary variant, and Android status bar color. And done. Next, go to Gradle build. Here I will write build features, and then inside it write view binding as true. Now click on Sync Now, and done. Then let me quickly add a background just to make the project look more presentable. You can skip this drawable step if you want to. And done. Now prerequisites are done. So go to activity-main.xml. Here I will create an edit text with a save button, and below that a display note button with a text view where the note will be displayed. And that's it. Let me quickly write the code. And done. You can pause the video and copy the layout code, okay? Now see, we have kept parent as relative layout. Then inside it two linear layout, and then inside it an edit text whose ID is notes edit text, and a button whose ID is Save Note button. Then outside a linear layout, there is a button whose ID Display Note button, and a text view whose ID is Note text view. And that's it. This is how it looks. Now go to main activity. Let me give you a quick overview what exactly we are going to do. So we will initialize share preference with a name. Then inside the Save Note button, we will store the data using share preference methods. And then lastly, inside the Display Note button, we will retrieve the data and display it on text view. And that's it. So first, let me quickly set a binding. And done. Then declare share preference. And done. Now I will initialize it as share preference is equal to get share preference. This is very important method to store name of the share preference and its mode. So inside it, I will write node data as a share preference name and then context mode as private. This is a way to specify the access mode for your share preference. In this case, you are using mode private, which means only your app can access this share preference. Got it? Then we need to store data when the user will click on Save Note button, right? So for that, I'll write binding dot save note button dot set on click listener. And then inside it, first we will take the input from user through edit text. So let me quickly write it. And done. So whatever the text user will write in notes edit text will be stored in the note variable. Then remember, in SQLite database, we used to define access mode for database like writable database or readable database. Likewise, we need to specify here as well. So I'll write well shared edit as share preference dot edit. Means the preference can be modified or edited. Now write dot put string. So put string is a method to store share preference using a key. So I'll write key as note. This is the key you are giving to the piece of information you are storing, that is note, through edit text. And this note is an actual content that you need to store. Then finalize everything by using apply method. And then I'll throw a toast as note stored successfully. Lastly, once the note is stored, you can wipe off the edit text using clear method. Simple, right? Now, when the display note button will be clicked, then it will retrieve the note and display it on text view. So to do that, first write binding dot display note button dot set on click listener on it. And then inside it, I'll retrieve the data first. So write will stored note is equal to shared preference dot get string. See, to store the data, we have used put string method, and to retrieve the data, we have used get string method. Got it? Then inside it, write the exact key, that is note. And then I'll keep the value as null, which means it will act as a default value that will be written if there is no value associated with the key note. And then the data will be stored in the stored note variable. Then lastly, display the note. So I'll write binding dot note text view dot text is equal to mention the stored note variable where the actual note is retrieved and stored. And that's it. We are done with the coding. Now let's run the app. See, this is how it looks. I'll quickly write here some note. And now I'll click on Save Note. And see, the toast says as note stored successfully. Now I'll click on Display Note. And look, the note is displayed here. Perfect. Also, let me quickly show you where exactly share preference is saved. So go to Device Explorer while the device is in running mode. Then go to Data, and then again Data, and then inside it find your project's package name. Here it is. Click on it, then go to Share Preference folder, and here you will see a share preference name, that is Node Data. I'll click on it and see it's an XML file where the exact node is stored using map attribute. And that's it. You can follow us on Instagram or join our Telegram group for more updates. Link in the description box. So yeah, that is it for the video. If you are new to this channel, then please consider subscribing to my channel, and I'll see you in the next video. Hey everyone, welcome back to my channel. In this video, we will learn data binding and view binding one by one with their examples. So first, let's understand what is data binding. Data binding is a technique that allows you to establish a connection between UI components and the data. See, in very simple language, it's like giving a variable to text view directly in the XML layout. I repeat, variable, not ID. So usually we assign variable to a particular UI component in activity, right? But in data binding, we can directly assign it in XML layout. Got it? This is how we enable data binding in Gradle module. Build features, and inside it data binding is equal to true. Now next is what is view binding. See, view binding is a feature that simplifies the process of interacting with UI components. Basically, it replaces findViewById method. And also in findViewById, if we wrote incorrect ID or maybe not initialize it, then it will obviously going to lead incorrect view typecasting or null reference. So to avoid such cases, view binding was introduced. This is how we enable view binding in Gradle module. Build features, and inside it view binding is equal to true. Now what is the difference between data binding and view binding? So view binding is a subset of data binding. Like whatever functionalities view binding can perform, that can be performed by data binding as well. But whatever functionalities data binding perform, view binding cannot. In simple words, data binding can be used as a substitute to view binding, but view binding cannot be used as a substitute to data binding. Like data binding can replace findViewById, and it can also connect data in UI, while view binding can replace findViewById, but it cannot connect data in UI. Got it? We have previously used view binding in most of the projects, so I assume you are quite familiar with it. And even if you're not, then let's understand it better through examples. This is an empty project where I will implement view binding as well as data binding one by one. So first, let's start with easy one, that is view binding. Step number 1 is to enable view binding. So go to Build Gradle app, and inside the Android brackets and below the Kotlin options, here write Build Features, and then inside it write view binding is equal to true. And that's it. Now click on Sync Now, and done. Then go to activity main.xml. Here we will create a simple linear layout with a text view and a button. So let me quickly create it, and done. See, parent layout as linear layout, and inside it a text view whose ID is also a text view, and then a button whose ID is also a button. And that's it. There is no functionality or any logic in it. I'm just demonstrating you like this will be your UI components. Now go to main-activity.kt. First, let me show you the traditional method, that is by using findViewById. See, this is where we declare the variable, and then using findViewById, we initialize the UI components. But with findViewById, there are chances of wrong IDs or null reference. So to avoid that, let's go for view binding. Also, you might be wondering what's wrong with this method. It's easy, then why the need of view binding? Because if the project is small with less UI components, then it is fine to use findViewById. But imagine an XML layout file with 6 buttons, 5 image view, 10 text view. Then in that case, you can't keep writing findViewById for each one of them, right? Hence, that's where we will need view binding. Got it? So we have already enabled view binding in Gradle, and now we need to write 3 lines of code just to declare and initialize it. First, write private let init where view binding as activity main binding. Tell me in which activity we are currently in. Main activity, right? And in which XML layout we are trying to connect? Activity main.xml, correct? So it will be activity main binding. Consider if the layout name is activity login, then it will be activity login binding. And if the layout name is activity sign up, then it will be activity sign up binding. Do you see a pattern? So prefix is XML layout name, that is activity main, and suffix is binding. Always remember that the declaration is dependent on layout file name, not on activity. Got it? Let me show you. If I rename main activity as maybe login activity, so see, still no error. But now I'll rename XML layout as activity login. And see, there is an error. Now it will become here as activity login binding. Got it? Hence, declaration is dependent on XML layout file name. Next, we have already declared it. Now to initialize it, write the variable as binding is equal to activity login binding dot inflate as layout inflator, means to fetch the layout. Then we usually attach XML layout in set content view, but now instead of it we will write binding dot root, means to attach the entire layouts. Basically you can access any UI components from it. Now all the setups are done and it's time to actually use it. See, I want to set a text on text view. So to do that, first we need to access it. So for that I'll write binding, that is a variable, then dot. So when you write binding dot, it will instantly show you a list of UI components. See, we have text view, then button, then container, everything at one place. So out of it, I'll choose text view, then dot, text, and some random text on it. And that's it. Now I want to set on click listener on button. So first to access it, I'll write binding dot, and out of this list, I'll choose button UI component. Then dot, set on click listener on it. And that's it. Then inside it, you can perform any actions. Did you see? We don't need to declare or initialize the button. We just wrote binding dot, and then we had a list of UI components in it. Cool, right? And that is what view binding is all about. Also make sure to remove old activity import, otherwise it will throw error. Now let's try data binding. I'll clear everything and back to empty project. Now, whatever we performed in view binding, same things can be performed in data binding as well. But view binding is not capable to establish a connection between data and UI components. And that's when we use data binding. So first we need to enable it. Hence go to Gradle module. Below Kotlin options, here write build features. And then inside it write data binding is equal to true. And that's it. Now click on sync now. And done. But if you'll notice here, it throws a warning as you need to add a Kotlin kept plugin. So to do that, in the same Gradle module file, you will find a plugin set where add a new plugin as id kotlin KAPT. And then click on sync now. And that's it. So data binding is enabled, and now let's set up. First go to activity main.xml. Here we have previous XML layout where linear layout as a parent layout, then inside it a text view whose ID is also a text view, and below it a button whose ID is also a button. And that's it. Now here comes a twist. As I said, data binding connects UI components with data. So text view and button is our UI components. But where is data? So just above the parent linear layout, we will create a layout with all the necessary declaration. So let me quickly write it. And done. See, no linear layout, no relative layout, no constraint layout, just a layout. The closing layout will be at the end, means it will cover all the UI components in it. Now inside the layout and above the linear layout, we will add a data. So I will write data, and inside it I will write variable, and then again inside it I will write variable name as message and its data type as string. And that's it. Once the data variable is created, then we will assign it to the UI component directly in the XML layout itself. And that's what the magic of data binding is. So we will assign this message variable to text view. How? Write text as @ curly brackets and mention the variable name, that is message. Simple, right? See, ID is text view and variable is message. Both of them are different. Then come to main activity.kt. Here first we will declare it as private, latent it where binding as activity main binding. I have already explained it in view binding. Then we will initialize it as binding is equal to data binding util dot set content view, and here mention this and the XML layout, not the root. And that's it. So data binding is declared and initialized, and now we will see how are we supposed to use it. Okay, so I'll write binding dot, and here you will see a list of UI components as well as variable name. So I'll select message variable. See, if I would have go for text view ID, then this is how the code would have looked. But as I chose variable itself that is assigned to text view, I can skip text view ID as well as dot text. All I have to write is equal to as some string. Got my point? Also, as I said, data binding can do the job of view binding. So in that case, if I want to access button, then I'll write here binding dot, I'll choose button ID, then dot set on click listener on it. Then inside it you can perform any operations. And that's it. I hope you have understood view binding as well as data binding. So make sure you use either one of them in your next project. I'll recommend to go for view binding. Okay. So yeah, that is it for the video. If you are new to this channel, then please consider subscribing to my channel, and I'll see you in the next video. Hey everyone, welcome back to my channel. In this video, we will learn one of the components of MVVM architecture, that is ViewModel. So first, let's understand what is MVVM. So in very simple language, MVVM architecture gives your project a proper organized structure with the help of its three components. First is model, then second is view, and then third is ViewModel. Got it? I'm not going in detail about view and model because today our focus is only on ViewModel. So later in upcoming video, I'll cover them. But to understand ViewModel, we need to know little bit about view and model too. So let me give you a quick overview about them. See, in very simple language, view handles the user interface, basically all the UI components, design, XML and all. And model represents the data. It could be local data such as room or SQLite, or it could be remote data source such as Retrofit, API and all. Got it? And then comes the view model. As you already know that view handles UI and model represents data. But now the question is, how will UI and data will communicate with each other? And that's where ViewModel comes into the picture. So ViewModel acts as a bridge between view and model. It is responsible for preparing and managing between data and UI. See, model is responsible for only data and view is responsible only for UI. But ViewModel is responsible for the communication that takes place between them. Communication as in actions that needs to be performed. Like, I'll give you an example. Consider a notes app where notes database is SQLite or maybe room database as data, that is basically a model. And recycler view, list view that displays the note as UI, that is basically a view. And then comes the view model, which basically acts as a mediator between them to send and receive request. Request as in read the data, write the data, update the data or delete the data. This processing can also be done using LiveData. I'll cover this topic in the next video, so stay tuned for that. But for now, let's understand ViewModel in detail through an example. So open Android Studio, choose Empty Views activity. Name the project as Learn ViewModel. Let me give you a quick overview what exactly we are going to create. So we will be creating a counter app, like when the user will click on the button, then the count will increment by 1. It will go like 0, 1, 2, 3, that way. I know it's a very simple app, but our motto is to understand how can we use ViewModel and other two components as well. So let's create it. First, let's do the prerequisite. So go to colors.xml. Add color as red with hex code as FF3131. And then next go to themes.xml. Add all the three items: color primary, color primary variant, and Android status bar color. And done. Then go to build.gradle. Here we will add view binding. So write build features. Then inside it write view binding is equal to true. And then click on sync now. And done. Now to use ViewModel, we will require ViewModel dependency. So let me copy paste it. And done. Then again click on sync now. And done. You can find the dependency in the description box. Also, let me quickly add background drawable just to make the app look more presentable. You can skip this step, okay? Close all the tabs. Now go to activity main.xml. Here I will create a text view that will display the count and a button that will increment the count. Simple, right? So let me quickly create it. And done. See, this is how it looks. We have a constraint layout as our parent layout. Then inside it, a text view whose ID is text view counter. And then below it, there is a button whose ID is button increment. And that's it. This text view and button are UI components. That is basically a view. Now view is done and then comes the view model. We will create a separate class for view model. Okay. So right click on it and create a new Kotlin class file. I'll write the name as my view model. And done. Now listen to me carefully. First, we will extend the class as view model. Then next, we will create instruction that needs to be performed on the data. But where is data? I mean model. See, as this is a very simple project, so there is no such big database like SQL or room database. Here we have our data as private var counter is equal to 0. This counter variable is a data, or you can say model. Got it? So we have view as well as model, and now it's time to connect both of them via view model class. As I previously said that view model send and receive the request such as create, read, update or delete data. So here we will perform two requests. First is to read the data and second is to update the data. Data as in counter value. Like read counter will fetch the count and display it, and update counter will increment the count. Got it? Let's implement it. First, create a function for read. So fun get initial counter. It will return the initial value of counter, that is 0. So as the return value data type is integer, so I'll write here as int, and then inside it return counter, that is 0 itself. Simple, right? Next, as we want to update the count, so I'll create an update counter function. So I'll write fun get updated counter. Again it will return an integer, so I'll write here as int, and then inside it, it will return incremented counter. Now beginners might have confusion with plus plus counter. Why is it not counter plus plus? See, if it will be counter plus plus, then in that case initial value is 0, and when you click on increment button, then the next value is also 0, and then again you click on it, then next value will be 1 and so on. But if it will be plus plus counter, then in that case initial value is 0, and when you click on increment button, then next value will be 1, and then again you click on it, then next value will be 2 and so on. Getting my point? So in counter plus plus, it consider itself first and then increment the next value, while in plus plus counter, it directly increment the next value. Got it? Now view, model and view model, everything is ready. Let's connect all of them in main activity. First, let me quickly set up binding. And done. Next, we need to access MyViewModel function. So for that, we need to call the MyViewModel class. So let me quickly declare it. And done. Now I need to initialize my ViewModel. So I'll write ViewModel provider. See, ViewModel provider is a utility class provided by ViewModel library that helps you to create and retrieve instances of ViewModel classes. For us, it's our MyViewModel class. So first I'll write this as owner, this as in main activity itself. Then using get method, I'll retrieve the MyViewModel class. Then next we need to set initial value on our text view. Initial value is basically 0 only. But if you remember, we have created a getInitialCounter function in MyViewModel class, right? Then MyViewModel.getInitialCounter function dot toString, because as you remember, function was written in integer. So to display it on text view, we need to convert it to string. Got it? So initial value is set as 0. Now set onClickListener on button increment. And then inside it, on the same text view counter, it will display the updated counter value. So I'll write MyViewModel dot get updated counter dot toString. And that's it. Now let's run the app. See, it's initially 0. Now I'll click on increment button. And look, the count goes like 1, 2, 3 and so on. Perfect. But if you are new to these topics, you will be wondering why there is a need to do all of these things. Like, why can't we declare counter 0 here itself and increment it directly? Why to make such chaos, right? Let me clear your doubt. See, first thing, that view model makes everything structured. Like model, view model, everything is separated and organized. If you would have created everything in same activity, then that would have been more chaotic, right? And second, the very important reason is that ViewModel can handle system configuration changes very well. System configuration as in screen rotations. Like, I'll show you an example. This is duplicate counter app project, but without using ViewModel. Everything is in same activity, and now see, it works exactly same. But here comes the twist. I'll increment the count. And if I rotate the screen, then look, the count went back to 0. Again, I'll increment it and then rotate the screen. See, again the count went back to 0. It's like every time you rotate your phone, the activity will start from the beginning. That will be annoying, right? Hence, ViewModel is used to overcome this issue. This is our counter app project using ViewModel. Here I'll increment it and then rotate it. And see, even after the screen rotation, the counter value remains as it is. Now, I'll increment it. And again, I'll rotate it. And see, again the value is as it is. Got my point? And that's it. So yeah, that is it for the video. If you are new to this channel, then please consider subscribing to my channel. And I'll see you in the next video. Hey everyone, welcome back to my channel. In this video, we will learn about LiveData with ViewModel. I have already covered ViewModel in my previous video, so I'll highly recommend you to watch that video first before watching LiveData, okay? Alright, coming back to today's topic. You remember these are the three components of MVVM, right? Model, View and ViewModel. Model represents the data, View is basically the UI, and ViewModel acts as a bridge between model and view. Basically, it is responsible for managing UI-related data and also for communication that takes place between view and model. Communication as in to send and receive requests to perform a particular action. Action as in to maybe update the data or delete the data. Got it? Now focus between view and view model. This is where LiveData resides, between view and view model. But what is LiveData? LiveData is part of Android architecture components, and also it is a data holder class that is observable, which means it can be used to hold and observe changes to the data. In very simple language, LiveData is like a special container that holds a piece of information, and it can let other parts of your app know when that information changes. Let's understand it through an example. Imagine you are building a weather app that displays the current temperature for a city. So instead of manually updating or refreshing the temperature display every few minutes or whenever it changes, you can use LiveData. It's like LiveData holds the temperature data and the UI observes it. Whenever the temperature data changes, then the UI automatically displays the updated temperature value, which makes your weather app more dynamic and responsive without the need for manual updates. Got it? Now let's understand LiveData more through the project. So open Android Studio, choose Empty Views activity, name the project as learn live data. Let me give you a quick overview what exactly we are going to create. So we will be creating a counter app where if the user clicks on the button, then the count will be incremented by 1, like 0, 1, 2, 3, that way. I know it's a very simple app, but again, our focus is to understand how can we use live data in the project. Also, it's the same app which we created before in ViewModel, but this time we will be creating it with the help of live data. The use of live data ensures that any observer of the counter live data will be notified automatically when count value changes. This in turn triggers the UI update in the activity. Simple, right? Now let's create it. First, let's do the prerequisite. So go to colors.xml, add the red color, hex code as FF3131, and then next go to themes.xml, add these 3 lines, color primary, color primary variant, and Android status bar color. And then now go to build.gradle app. Here add view binding, and click on sync now. And then as we want to use live data as well as ViewModel, hence we will require both the dependency. You can find them in the description box. Then click on sync now, and then close all the tabs. Now go to activity main.xml. Here I'll create a text view that represents the count and a button that will increment the count. So let me quickly create it. And then see parent layout as constraint layout. Then inside it a text view whose ID is text view counter. And then below it a button whose ID is button increment. And that's it. This is how it looks. Now comes the important part. As I previously said, live data is present between view and ViewModel. So view is our activity main.xml, and now let's create ViewModel. So right click on it, create a new kotlin class, name it as myViewModel. This is where the magic happens. I already showed you how ViewModel works. First is to extend class as ViewModel. Perfect. So previously inside it we created counter variable and its function, right? But now here inside it I'll create live data. First create a variable named as count live data. Then initialize it as mutable live data. And keep the data type as int. Now what is mutable live data? Mutable live data is a subclass of live data that allows you to modify the value it holds. This means you can change the integer value stored in the count live data. Then we need to initialize the value. So let me quickly write it first. And then, now see, init block is used to initialize properties when an instance of the class is created. Like in our case, init block is setting up the initial value as 0 of the count live data property. Next, we need to declare live data. So let me quickly write it. and done. Now see, here I have declared a variable that is counter live data as live data, which holds the integer values only. Then get block is used to retrieve the value of count live data and provide it as the value of counter live data. Lastly, I'll create an increment counter function. So let me quickly write it. And done. Now see, this increment counter function will be used when the increment button will be clicked. Basically, it will increment the number by 1. It goes like count live data dot value will retrieve the current count that is displayed on the text view, and then using question mark and colon, that is Elvis operator, it sets the default value as 0 and then increment it by 1. Simple, right? So quick overview, when you access the counter live data property, which we will do it in main activity, then it returns the value of count live data. This allows UI components to observe and access the counter value as live data without the need to directly access count live data. Great, right? Now let's move to main activity. This is where we will initialize the view model, observe the live data and increment the counter. So first, let me quickly set up binding. And done. Next, we need to access MyViewModel function. So for that, we need to call MyViewModel class. So let me quickly declare it. And done. Now I need to initialize MyViewModel. So I'll write MyViewModel as ViewModel provider. See, ViewModel provider is a utility class provided by ViewModel library that helps you to create and retrieve instances of ViewModel classes. For us, it's a MyViewModel class. So first, I'll write this as the owner, this as a main activity itself. Then using get method, I'll retrieve the MyViewModel class. This is how we initialize it. Next, we need to observe the live data. So I'll write MyViewModel dot counter live data. Remember, counter live data, not count live data. Okay? Then dot observe as this. Then create a count variable that will keep the count value. And then inside it, set the count on the text view counter using text method. Then add observer here. So here UI is observing counter live data, and whenever the count change, it will immediately update the text view counter. See, so simple, right? Lastly, set on click listener on button increment. And then inside it, write MyViewModel and access the increment counter function which we created in MyViewModel class. And that's it. We are done with the coding. Now let's run the app. See, it's initially 0. Now I'll click on increment button. And look, the count goes like 1, 2, 3 and so on. Perfect. The app is very easy. That's not even the concern. My concern is that you guys have understood how live data works. right? To make it easy for you, remember these 4 steps. First is mutable LiveData. Second is init block. Then third is LiveData. And then fourth is observing the LiveData. Simple, right? And that's it. Hey everyone, welcome back to my channel. In this video, we will learn about MVVM architecture and its 3 components. That is model, view and ViewModel. Out of these 3 components, ViewModel is a new concept for you. Hence, I have created a separate video on it in detail. So make sure to watch that video first, okay? You can click on the I button to watch. But now, in today's video, we will be covering model, view and ViewModel, all 3 of them in the same video and in the same project, okay? So first, let's understand what is MVVM. MVVM is an Android architecture that basically organizes your code into separate modules. Like, data will be stored in different module, UI will be stored in different module. Modules as in packages, which ultimately makes development and reuse of code simpler and faster. Like in corporates, usually multiple team members works on the same project, right? But imagine that project with no MVVM structure. Like data, UI, logic, everything in the same package. It will be so confusing for each member to understand that project, right? But now imagine the same project with MVVM structure. Let me explain it through an example. Imagine the code behind Zomato app. It literally have 1000 lines of code. Crazy, right? But more than that, imagine maintaining that code. But no, that's not how professional app works. They are built in such a way that they are well organized and structured. So if they want to update any feature, they will be able to quickly find it in the code because they know in which package which functionality resides. All the small projects might not necessarily require MVVM, but it is highly recommended to use MVVM or any other type of architecture when you create a professional app. Okay? Till now, you are aware what is MVVM and why is it required. So now, let's quickly understand its 3 components as well. That is model, view and ViewModel. So model represents the data, view represents the UI, and ViewModel represents the communication that takes place between view and model. Simple, right? See, whenever you create a project using MVVM, make sure to create 3 different packages inside it. That is model package, which will consist of all the data related activities. Then view package, which will consist of all the UI related activities. UI related activity does not only means XML file, but also the activities which define UI components in it, like main activity. And then ViewModel package, which will consist of all the UI related data activities. Got it? So now let's understand it better through an example project. Open Android Studio. Choose empty views activity. Name it as Learn MVVM. Let me give you a quick overview of what exactly we are going to create. So we will be creating a simple kids calculator app that just add 2 numbers. I know it's a very simple app, but again, as I always say, our focus is to understand how can we use MVVM in the project. Now let's create it. First, I'll do the prerequisite. So go to colors.xml. Add the red color with hex code as FF3131. And then, next go to themes.xml. Add these 3 lines. Color primary. Color primary variant. And Android status bar color. And then, now go to build.gradle app. Here add view binding. Click on sync now. And then, also as I'm using the latest Android Studio, so I guess there is no need of adding ViewModel dependency. But if you face any error regarding dependency, then simply add it in the Gradle module. Okay? I'll mention the dependency in the description box. Then let me quickly add a background just to make the app look more presentable. You can skip this step. Close all the tabs. Next, let's quickly design activity main.xml. Here we will have 4 important components: to edit text, 1 button, and lastly a text view to display the result. And that's it. So let me quickly create it. And done. Now see, the designing code is quite a lot as you can see. But as I previously said, focus only on 4 important components and their respective IDs. Let me show you. First, parent layout is a linear layout. And then inside it, this linear layout, card view, add text view is just to make app look more presentable. And then inside it, this is important, edit text, whose ID is edit text num1. Then next, edit text, whose ID is edit text num2. And then a button whose ID is calculate button. Then just a result text view, and then below it a text view whose ID is result text view. And that's it. I'll slowly scroll the code so you can pause the video and copy the code. And done. Now comes the MVVM part. This is where we will create different packages. See, inside com.example.learn_mvvm, this is our main package. And inside it, we will create 3 packages, that is model, view and ViewModel, right? So to create a package, right click on it. Click on new package. After this, write model and press enter. See, we have a model package ready. Similarly, we will create view and ViewModel package too. And done. Now, as I previously said, inside each package, we will have their respective activities. So first, we will create model activity, then view model activity, and then lastly, view activity, that is main activity itself. So let's do it step by step. First, we will create data, that is basically our model. So right click on model package and create a new Kotlin data class. Name it as calculator data. Here we will have all the data variables like first number, second number and the sum value. As I previously said, it's a very basic app, so the data will be very low-key only. Imagine maybe there is a notes app. Then we might have room database or SQLite database. But for now, it's just basic variable as a storage. So I'll write first variable as num1, data type as int. Then second variable as num2 as int. Then third variable as sum, that is also as int. And that's it. See, to add 2 numbers, first number will be stored in num1, then second number will be stored in num2, and then the result will be stored in sum variable. Got it? This is how variable will act as a storage to store the data. And done. Now next thing is to create view model, where I will give the instruction that needs to be performed on the calculator data. So first right click on view model package, create a new Kotlin class as calculator view model. This is where I will write the instruction. Instruction as in the logic to add 2 numbers. So first I'll extend view model. And then inside it, we will create a function as calculate sum. So write fun, calculate sum. And pass the parameters as num1 as int, and then num2 also as int. Then, as I said, instruction needs to be performed on model, that is basically our calculator data, right? So at the end of the logic, it should return calculator data. Hence, I'll write here as calculator data. And then inside it, the logic. What is the logic to add two numbers? You guys already know, that is to use AND operator. So it goes like, some variable will store the num1 plus num2 result. Simple, right? And as I said, lastly, it will return the calculator data. Hence, I'll create a calculator data object with num1, num2 and sum as its properties, which returns the object. And that's it. Alright, model is ready, view model is also ready, and now it's time to attach them with view. That is nothing but our main activity, which consists of all the UI components like edit text, text view and button. So first we will move main activity from main package to view package. And done. Now go to main activity. Here are three important things that needs to be done. First is to initialize view model, then add functionality on the button, and then lastly display the result on the text view. Simple, right? Before that, first let me quickly set up binding. And done. Now, as we need to access add function from view model, so for that we need to declare and initialize it. So view model is declared, and now let's initialize it. I'll write calculator view model as view model provider. See, ViewModel Provider is a utility class provided by ViewModel library that helps you to retrieve the instances of ViewModel class. For us, it's a calculator ViewModel class. Hence, I'll write this as the owner, this as in main activity itself. Then using get method, I'll retrieve calculator ViewModel class. And done. This is how we initialize it. Now, why are we not declaring or initializing calculator data as well, which is basically our model class? Because we have already created its object in view model, right? So this is what MVVM is. Data and view directly does not communicate with each other. They go via view model class. Okay. Then next, set on click listener on calculate button. And then inside it, first I'll take the input from the user through edit text. So let me quickly write it. And done. See, num1 variable will store the first number input that is given by user through edit text. And similarly, num2 will store the second number input. You already know text method and toString method, but what is toInt or null? Let me explain. ToInt or null basically converts the string that is obtained in toString to an integer. If the conversion succeeds, then it will return the integer value. Otherwise, it will return null. Simple, right? Then this is the always operator. It checks the result of toInt or null. If toInt or null returns null, then its default is set to 0. Got it? Lastly, we need to display the result. So first, create a result variable that will store the sum value. And how will we calculate the sum? Using calculate sum function that is present in calculator view model, right? So to access it, I'll write here as calculator view model dot calculate sum and pass the arguments as num1 and num2. The calculated sum is stored inside the result variable. And now using text method, we will display it on the text view. So I'll write here as binding dot result text view dot text as $sign to access the variable. So I'll write here as result variable dot sum. Where does this sum comes from? To check that, press Ctrl and click on it. See, this is where it comes from. Basically, it is a string interpolation that substitutes the value of result.sum into the string. Means, in a very simple language, whatever the result sum data is, that is displayed on the result text view. And that's it. We are done with the coding. Now, let's run the app. This is how it looks. I'll write here as 20 and here is 30. And then click on calculate button. And see, 50 is displayed as result. Perfect. App is very basic. That's not even the point. My point is how we implement MVVM. So let me quickly give you an overview. Look, we have 3 different packages: model, view and ViewModel with their respective activities inside it. In model activity, we have data. In ViewModel activity, we have model, object as well as the addition logic. Then in view main activity, we have connected our ViewModel with its UI component. And that's it. This is what MVVM is all about. At the end of this advanced series, I'll surely create a fully functional app using MVVM. Okay? So stay tuned for that, and for now you can follow us on Instagram or join a Telegram group for more updates. Link in the description box. Hey everyone, welcome back to my channel. In this video, we will learn about Room database. This is one of the most important topic in Android development. Also, as this is advanced series, so topics are kind of little tricky, but don't worry, I'll try my best to make it as simple as I can. So, as you already know, there are a variety of ways to store data, right? Previously, we have used Firebase real-time database, then SQLite database, right? And now, Room database. It's advanced, clean and high efficient than other database. Alright, let's understand Room database. But before proceeding with that, first we need to do a little recap about SQLite database because they are kind of related to each other. Hence, let's first understand SQLite database. So this is all bookish definition, so better focus on what I am telling you, okay? Now see, as you already know, SQLite database is a local storage present in your device that stores, retrieve, update and delete the data with the help of queries, right? We have previously created a Notes app using SQLite database with CRUD functionality. You can click on the I button to watch. But SQLite database has some kind of drawbacks as well as a lot of boilerplate code. Hence, to overcome that issues, Room library was introduced. Room database is a library that provides an abstraction layer over SQLite database. Now, what is abstraction layer? Basically, abstraction layer is a way of hiding the working detail of a subsystem. In our situation, subsystem is SQLite. In simple words, as I said, SQLite has a lot of boilerplate code, right? So Room database basically hides it and provides only the necessary code. We will see that differences in the next slide. But before that, let's understand more about Room database. It's a clean and efficient way to store, retrieve, update and delete the data. And it does not necessarily require queries to perform actions. Also, clean as in they are very structured like MVVM. How MVVM separates model, view and ViewModel. Similarly, Room database does the same by separating its component, which we will see in the upcoming slide. Also, it stores the data locally in the device itself. Got it? Then see, as I previously said, Room is an abstraction layer on the top of SQLite database, which basically handles the tasks that were performed by the SQLite Open Helper. And also, it brings a lot of customization that SQLite lacks in itself. In simple words, you can say it's a better version of SQLite database. But what makes it better than SQLite? Let's see the differences. First, in SQLite, there is no compile time verification of SQL queries. But in Room, it validates each and every SQL query at the compile time. Second, as your schema changes, schema as in database structure, okay? So it says if your schema changes, then in SQL, we need to update it manually. While in Room, it automatically updates it. Then third, as I said previously, Room avoids boilerplate code by directly mapping the database object to Java object, while SQL uses a lot of boilerplate code to do the same thing. Fourth, as Room is a new and advanced library, hence it works with LiveData, MVVM, RxJava and many more, while SQL does not. Next, remember in MVVM, this is view, this is ViewModel, then below it there is a repository that consists of model, which is basically Room database. This is where Room database resides. Got it? In the end of this advanced series, I'll be creating a project using Room and MVVM, which will clear all your doubts, okay? So stay tuned for that. Then next comes the important part, that is basically three components of Room. First is entity, second is DAO, that is database access object, third is database. These three components are responsible for making the application clean and structured. Each one of them is very important, so let's understand it one by one with the help of examples. Okay? First is entity. An entity is a class that represents a database table including its column data types and primary key. In simple words, there is an entity data class that will declare table name and all the columns present inside it. Let's see the sample code to understand it better. This is an entity data class named as user entity. Also, I thought of creating an entire Room database project, but it's quite huge, hence I'll cover it in the end of the series. But for now, we have sample codes for each component. To implement Room database, make sure to add Room database dependency in the Gradle module. Now let's have a look at entity data class. As I said, entity declares table name as well as column name, so this is how it looks. This @entity is annotation. Each component has its own annotation, like entity has @entity, DAO has @DAO, and database has @database. But what is annotation? Annotation is like a node that defines what actions are we supposed to perform. Like whenever we declare entity annotation, that means this is where we are supposed to declare table name and column. See, this is the list of all the annotation present in Room database. You will find this on internet too. Now back to entity class. So our table name is users, and this is not a normal class, it's a data class, okay? Then inside it we have three column name with their data type. First is ID, whose data type is long, and also it's a primary key. You know the concepts of primary key, right? Like if we associate primary key with a column, that means that column values will be unique. So here all the ID needs to be different from each other. Likewise, phone number and email column can also be a primary key, right? It is mandatory to declare one of the column value as primary key in Room database, okay? Next, we have a column name as name, whose data type is string, and then email, that is also a string. And that's it. See, it's so easy to write entity code, right? Now let's understand DAO, that is database access object. A DAO is an interface that provides abstract method to interact with database. Basically, it enables CRUD operation that needs to be performed on the entity. Sounds complicated? Let's crack it. First, let's understand what is an interface. So, interface is a collection of constant and abstract methods. Now, what is abstract method? Abstract method usually don't have body. Like, they does not have any implementation details present in it. Let's have a look at sample code of DAO. This is an interface whose class name is user_DAO. As I said, each component has its own annotation. So for DAO, it is @DAO, which lets you create an interface with all the abstract methods present in it. Entity is a data class and DAO is an interface. Clear, right? Now let's have a look at all the abstract methods. As I said, abstract method means the method without a body. So as you can see, we have CRUD annotation with suspend keyword, but there is no body, right? But what is suspend keyword? Suspend keyword makes sure that whatever the function is, that needs to be performed in the background thread for asynchronous database access. means that function can be paused or resumed without blocking the thread on which it's running. All this function needs to be performed on the user entity which we created before. That is nothing but the table and columns, right? See, don't focus on each and every line of code because it's just a sample code. Hence, I'm focusing only on the syntax code. See, as I previously said, you don't need to write queries. So see, we have insert annotation, then update annotation, and then delete annotation with their respective function. But Roam also provides us to write custom queries using query annotation. Like this query retrieves all the data from the user's table, and this one retrieves only the ID from the user tables. Got it? So we have table in entity and instructions in DAO, and now we need to connect both of them through database, right? Hence, let's understand the third component, that is database. It is an abstract class that serves as a main access point to the SQLite database, and also it connects user entity and user DAO. Let's have a look at sample code of database. This is an abstract class called as user database. Abstract class is different and abstract method is different, okay? So I already explained what is abstract method, basically method without body. An abstract class is similar like interface which contains mixed methods like methods with body as well as methods without body. Got it? Now here it has @database annotation that declares user entity with its database version. And then an abstract class named as app_database that extends room database. Basically, it serves as the main entry point for interacting with the database. Then inside it, we have an abstract function that defines an abstract method. That is user DAO with no body, right? This method is used to obtain an instance of the user DAO interface which provides method to interact with the database table associated with the user entity. Then it defines a companion object and uses create database method to initialize the database. See, I'm not going to explain it in detail because it's just a simple code to give you an idea about database component, right? But we will understand it in detail while creating the project, okay? And that's it. I know there was a lot of information to observe, but each and every point is very important. And also, while learning Room database, we came across so many new concepts like interface, abstract class, abstract method, suspend keyword, annotations, right? Here it is a quick little summary for you. Pause the video and read it carefully. If you want, you can take a screenshot of it, okay? Hey everyone, welcome back to my channel. In this video, we will learn about navigation component library. I'll be using navigation in one of my upcoming projects, hence I wanted to cover it, and also it is one of the most important topic when you will deal with Jetpack Compose. It's super duper easy to understand, but there are few terms that you need to remember in navigation component, okay? Alright, let's understand what is navigation. First, don't see the technical definition of it, just simply answer the meaning of navigation word. I'll say to shift from one place to another place. Basically, you can say to navigate from one screen to another screen. Sounds simple, right? Let's see the technical definition of it. It says the navigation component is a library that can manage navigation flow. That's what we saw in the above definition, right? Basically, it navigates from one screen to another screen. And that is nothing but navigation flow. Got it? Then, it can also manage transition animation. Look, you know how PPT works, right? They move from one slide to another slide, and sometimes to make PPT more creative, we put transition between the slides, right? Similarly, to navigate from one screen to another screen in the app, you can add a transition between them. Cool, right? Then deep link. Deep link is a link that takes you directly to a specific screen within your app. And lastly, obviously, while navigating from one screen to another screen, you may have to pass some data. That is also possible with the help of navigation. So I guess you got an idea what exactly navigation does, right? So all of these things are managed using destination, actions, visual editor, and components. These are all technical terms. In simple language, destination is the target screen on which we are supposed to land on. Then action is basically from which screen to which screen. Next, visual editor is like, you know how we have XML editor where we can drag and drop UI components. Similarly, there is a visual editor which will help us to manage navigation flow. And then we have 3 components: navigation graph, navigation host, and navigation controller, which we will cover in the upcoming slides, okay? So I guess we are pretty much clear about it. Now, if you are aware with Android beginner concepts, then you might be wondering, same things like navigating from one screen to another screen or passing the data, that can also be done by using intent. Then why is there a need of navigation? Well, let me clear that. First of all, both of them are completely different from each other. I'll give you 3 major points to differentiate. First, in intent, we usually write the target activity class name, right? But in navigation, we define a path and a destination that makes the code more organized. Then second, the important point, that is intent are usually used for navigating between activities, while navigation is used for navigating between fragments. If you remember navigation drawer or bottom navigation code, there we used to have a block of a code that replace fragment code, which consists of fragment manager, fragment transaction, right? But now in advanced and latest project, we use navigation. Then third point, it says in intent, we have to manually manage the back stack. Means, what are we supposed to do when back button is pressed? While in navigation, it automatically handles it. Clear, right? Moving on to the next slide, as I said, all this navigation flow is handled by these 3 components. That is navigation graph, navigation host, and navigation controller. Let's understand it one by one. First is nav graph. I'll tell. Like how we have separate menu directory in resource folder, similarly, we will have a separate directory for navigation, which will consist of nav graph. Nav graph is like a visual editor where we will have destination screens, basically all the fragments present inside it. This is where we assign paths and navigate from one screen to another screen, but all of this is possible only when we will have a host as an activity layout, means activity XML layout. That could be activity main.xml, which will act as a nav host, under which all the fragments will be managed. So nav host is basically a container that we are supposed to add in the activity layout. And that container is nothing but fragment container view itself. You will understand it better when we will implement the example project. Now we have nav graph that is hosted by nav host and nav host that is controlled by a third component, that is nav controller, which is present in your main activity. It programmatically controls and navigates. Programmatically as in through logic. This is all theoretically, but everything will be cleared once we will create the example project. So let me give you a quick overview. So there will be 3 fragments handled by one activity. First fragment will be a welcome screen that has 2 buttons in it, login and sign up button. When you will click on login button, then it will navigate you from welcome screen to login screen. And when you click on sign up button, then it will navigate you from welcome screen to sign up screen. And that's what navigation is. I know, it's very simple, but very important as well. There are more concepts in it like transition, deep linking, passing the data, which I'll cover in upcoming videos, maybe in Jetpack Compose series. But for now, let's understand how these 3 components will contribute. See, nav graph will consist of all the 3 fragments with their respective part. Then all these fragments will be handled by one activity. In our project, activity main.xml will act as a nav host, and main activity will act as a nav controller. So let's create it. Open Android Studio, choose empty views activity, name it as Learn Navigation. And done. Let's do the prerequisite first. Go to colors.xml, add red color with hex code as FF3131 and done. Then go to themes.xml, add these 3 lines, color primary, color primary variant, and Android status bar color. And done. Then as it's a login screen, we will require fancy edit text. So let me quickly create it. And done. Then just to make app look more presentable, I'll add background drawable. And done. Please skip this step. Then as it's a library, so we need to add dependency. So go to Gradle app. Here add a plugin. Then below it, add both the dependency and also don't forget to add view binding as well. And also, as navigation is a new concept, so it requires compile SDK as 34 or greater. Okay. Do not click on sync now yet. Then go to Gradle build project. Here add the entire build script. Also, build script should always be at top and plugin should be below it. Now you can click on sync now. And done. You can find all the dependency in the description box. Next, as I said, we will have one activity that is a default activity, main activity, and 3 fragments: welcome fragment, login fragment, and sign up fragment. So let me quickly create them. And done. I'll quickly clear all the unnecessary codes from each fragment activity. And done. Now close all the tabs. Then let's design all the fragments XML. First go to fragment welcome. Here we will create 2 buttons. So let me quickly create it. And done. See, linear layout as parent layout. Then inside it a linear layout, and then inside it 2 buttons. First is to go to login button and second is to go to sign up button. And that's it. Next, go to fragment sign up. Here we will create 2 edit text and 1 button. So let me quickly create it. And done. See, 2 linear layout and inside it a edit text whose ID is sign up username. Then another edit text whose ID is sign up password. And then a button whose ID is sign up button. And that's it. Next, go to fragment login. Here we will copy paste the sign up code. And done. Now change the IDs as login username, login password, login button, and also change the other required details. And done. So all the fragments are ready, and now it's time for navigation component. Our first navigation component is nav graph. So let's create it. Right click on resource folder, create a new directory, keep the resource type as navigation, and done. Then inside it create a new navigation resource file. name it as nav graph and click OK. This is our visual editor. Remember I said there will be a visual editor where we will add all the fragments with their respective path. This is where it is. But I also said that everything is handled by host. So as you can see over here, it says no host found. Hence, first let's assign the host. So go to activity main.xml. Here we assign host, and in main activity we assign controller. But how do we assign nav host to activity main? Remember I said nav host is a container. In palette section, we have something called as containers. Click on it. Then keep scrolling till you find nav host fragment. Here it is. Also an easy way to find it, simply search it. First, remove the default text view. Now drag and drop nav host fragment in the middle of activity main. Perfect. Choose nav graph which we created before and done. Then constrain it from each side. And that's it. Our host is ready. How simple was that? Let's see how it looks in the code. Look, nav host fragment is nothing but fragment container view itself. I'll rename the ID as nav host fragment container view. Keep the name as it is and default nav host as true. Also, it automatically assigns our nav graph. And that's it. Now our nav host is ready. So let's quickly set up nav graph as well. Also remember this. First create nav graph file, then set up nav host, and then go back to nav graph and set it up. What I mean by that is you need nav graph file to set up nav host and nav host to set up nav graph. Getting it? Come back to nav graph. Here we will create destinations, that is fragment itself. So click on plus sign. First choose welcome fragment. Then next choose login fragment. And then next choose sign up fragment. You can rearrange it as you want. Also, as this is a launcher fragment, so assign it as start destination. Once all the fragments or destinations are created, then let's give them a path or actions. So can you see a spot here? Start an arrow from welcome fragment to login fragment. And see, there is a path. Similarly, we will create another path that will go from welcome fragment to sign up fragment. And that's it. See, so easy, right? Let's see the code. This looks kinda complicated, right? Hence, design is preferable. But still, you should be aware with all these terms. Look, the start destination is welcome fragment, okay? And inside navigation, we have our 3 fragments. That is login fragment, sign up fragment, and welcome fragment. Also, as you can see, login and sign up does not have action present in it, while welcome fragment has 2 actions in it. Because both the path comes from welcome fragment, hence it has 2 actions present in it. Like first action is from welcome fragment to login fragment, that is basically our ID. And destination obviously as login fragment. Similarly, second action is from welcome fragment to sign up fragment, and destination is sign up fragment. And that's it. So our nav graph is ready as well as nav host is also ready. And now it's time to set up nav controller. Hence, go to main activity. Here we will set up our nav controller. First, declare it. And done. Then create an override function called as onSupportNavigateUp. Here, initialize nav controller as find nav controller, and inside it, mention the fragment container view which we created before in activity main. Then return it as nav controller dot navigate up or super dot on support navigate up. Let me explain it. See, this line is responsible for determining whether the navigation action should be handled by the nav controller or by the parent class. If navigate up returns true, then navigation flow will work as defined. But in case it returns false, means due to certain reason it fails to navigate from one screen to another screen, then in that case, it falls back to the default behavior provided by the parent class. Got it? Now once all the three components is successfully set up, you can use it in your fragment. Like I'll show you. Go to welcome fragment. This is where we have two buttons, right? Login and sign up button, where each one will redirect to their respective fragment. So to do that, first we need to set up binding. And done. This is how we set up binding in fragment. Then we will write the code between the binding code here. First, write binding dot go to login button dot set on click listener. Then, when the user will click on login button, it will navigate to login screen, correct? So to do that, first let me write the code and then I'll explain. And done. Now see, it refers to the view that was clicked. In our case, that is go to login view. Then find nav controller is a function provided by navigation component. It allows you to find the navigation controller associated with the current view or fragment. Our nav controller is present in main activity, right? So using find nav controller, it will navigate from one screen to another screen, like from welcome fragment to login fragment. Click on it and see, it leads us to nav graph. This is where the ID is. Similarly, we will write the code for go to sign up button as well. It is the view, then find nav controller and then navigate it from welcome fragment to sign up fragment, and that's it. We are done with the coding. Now let's run the app. See, our first screen is welcome fragment. Then I'll click on login button and here it is login screen. Then I'll click on sign up button and here it is sign up screen. I know the project is very basic, but all I wanted to show you is that how navigation component works, okay? Hey everyone, welcome back to my channel. In this video, we will learn about coroutines. I know coroutines is a very new concept for you, but it is very easy. We will understand the basics of coroutines through an example later, okay? First, let's see what is coroutines. Coroutines are a concurrency design pattern that allow for sequential execution of tasks in a non-blocking manner. In very simple language, coroutines manages multitasking very well by dividing its processes into multiple threads. Now, what is thread? Thread is like a pipeline where all the processes take place. Processes as in UI interaction, image loading, file downloading and all. So this is our main thread. Here all the processes take place. Now imagine how tough it is to handle so many processes by a single thread. The app will lag, it will freeze, even it can get crashed. And that's not how professional app should work, right? Here coroutines was introduced to overcome the burden that was put on main thread. But how will it overcome? By dividing the processes into multiple threads. You can call it coroutine thread or background thread. Now as you can see, we have two threads. One is main thread that is handling UI interaction, logical operations and arithmetic operations. And then there is a background thread that is handling file downloading and image loading. The processes are divided into two threads, which makes coroutine non-blocking because they allow for sequential execution of tasks without blocking the main thread. That ultimately improves app performance and prevents lagging or freezing. Great, right? Now in coroutines, there are few terms that you need to understand, for which first we need to see how do we create coroutines. Here it is. To implement coroutines in the app, you need to add this dependency. Then this is a general syntax, coroutine scope, dispatcher.io.launch. To understand coroutines deeply, we need to understand these two terms, scope and its type and dispatcher and its type. So first, let's understand what is scope. Scope basically determines the lifetime and behavior of coroutines by executing asynchronous code. Now what is asynchronous? Asynchronous in coroutines means that the task can be executed at the same time without blocking the main thread. Got it? So we have two types of scope. First is global scope and second is coroutine scope. You can use any scope based on your requirement. First, let's see what is global scope. Global scope is not tied to a specific coroutine. It allows tasks to be executed concurrently, means at the same time without being limited by the lifecycle of individual coroutines. While coroutine scope is tied to activity lifecycle or fragment lifecycle, means consider coroutines is running and suddenly the app is destroyed, means removed from the recent app list, then in that case coroutines will also be destroyed because obviously it was dependent on lifecycle. But if you have used global scope, then coroutines won't be destroyed because obviously it was not dependent on lifecycle. Easy, right? Then let's see what is dispatchers. Very simple definition. Dispatcher defines which thread to use for executing the code, like main thread or background thread. That we need to define, okay? There are three types of dispatcher. Let's see each one of them. First is dispatcher default, second is dispatcher IO, and third is dispatcher main. Basically, which dispatcher are we supposed to use for which process? Like for CPU-based operations such as computing or sorting algorithm, then we are supposed to use dispatcher default. Then for IO-based operations such as network request or file operations, we are supposed to use dispatcher IO, that is our background thread. Then for all the UI-related operations like set on click listener or button or set text, we are supposed to use dispatcher main, that is our main thread itself. Got it? Wait, come back to the previous slide. Look, here main thread is handling all the UI related and mathematical operations, and background thread is handling all the IO related operations like file downloading and image downloading, right? See, default thread is main thread only, which is pretty good at handling UI related operations such as set on click listener and all. But if you tell main thread to handle file downloading as well, then it will be like, I can't do it, tell dispatcher IO or background thread to handle it. Now let's understand it better with a simple coroutine example project, okay? Open Android Studio. Here is an example project that I created to show you the difference between an app without coroutine and an app with coroutines. First, let me give you a quick overview. This is where we have added the view binding. Then come to activity main.xml. Here we have created two processes in the same screen. First is counter process, which we have to manually update the count by clicking on the start counting button. And then second process is where a file downloading will be done. Of course, there is no actual file getting downloaded. It's just a demo, okay? So to create this UI, first I have used constraint layout as a parent layout. Then a text view representing process 1. Then another text view which represents the count whose ID is count number. Then a button whose ID is count button. Then another text view for process 2, and then a button whose ID is download button. Got it? Now come to main activity. I have not used coroutines yet. See, we have implemented binding, then kept initial counter value as 0. Then first button is count button. The logic says when you will click on the count button, the count number, that is the text view, will be incremented by 1 every time. Then we have another button which is download button. As I said, it's not gonna download an actual file, but it's just a representation of how a file is downloaded. Like I have used a for loop whose variable is I that starts from 1 and goes up to like lakh. Then inside it there is a log tag. This log tag will be visible in logcat. So it goes like we have used tag as a representation for log. Then inside it a message that says downloading I, that will be the number going from 1 to lakh in which thread. Like thread.current thread name represents the thread name in which all this process is happening. Either it will be main thread or in background thread. It will just display the current thread name, that's it. Simple, right? Now remember what I said while explaining it. Default thread is main thread that handles all the UI related operations such as set on click listener. It will handle it wisely. But there is a file downloading process as well. That too has to be handled by the main thread. But do you think it will be able to handle it? Let's find out by running the app. Now see, I'll open logcat so you can see the fake downloading process. This is old process, so I'll quickly clear it. I'll use tag as a reference. Then I'll click on start downloading button. See how fast it is getting downloaded on the main thread. But in the middle of the process, I'll start another process as well, that is start counting. And look, it is lagging, it is freezing and finally got crashed. It was tough for main thread to handle two different processes at the same time in the same thread. Hence, we will use coroutines. Let's modify the code. So go to build.gradle. Here in dependency, add the following coroutine dependency. You can find it in the description box. Then click on sync now. And done. We won't modify activity main code, so directly come to main activity. Here set on click listener is handled by main thread. Fair enough. But we don't want file downloading to be handled by main thread. Instead, who should handle it? Of course, coroutine or background thread. So how do we create coroutines? First is to decide which scope. Remember global scope or coroutine scope? I am fine using coroutine scope, even if it is dependent on the lifecycle. So I'll write here as coroutine scope. Then I have to decide which dispatcher are we supposed to use. As I am performing file downloading process, which obviously means I need to use dispatcher IO. So I'll quickly write here. And then finally, launch will execute the below code. So I'll cut paste it. And done. Now this process will run in main thread and this process will run in the background thread. Easy, right? Let's run it. Look, I'll click on start downloading and see, here it says the downloading is running on the background thread. Simultaneously, I'll click on start counting button as well, which is running on the main thread. Look, no lagging, no freezing and no crash. As both the processes are in different thread, hence it is working perfectly fine. Great, right? So that's it. This was all the basics of coroutines. Later in future, I'll cover coroutines advanced concepts as well. Okay? Hey everyone, welcome back to my channel. In this video, we will learn about retrofit. It might sound like a tough topic, but trust me, it is very simple. I'll be releasing this video in Hindi as well on Android Knowledge 2.0 channel, so make sure to subscribe my second channel as well. Link in the description box. Now let's understand what is retrofit. This is our bookish definition. Let me tell you what exactly retrofit is. Retrofit is a library which is used for making network requests and handling API communication in applications. Basically, it communicates between web server and application. Web server as in API. Now what is API? API stands for Application Programming Interface. It provides a set of rules and protocols that allow different applications to communicate with each other, enabling developers to access and utilize functionality from external services within their own applications. In very simple language, consider I'm creating an app like Ola Uber where I need map functionality. So either I have two options, to create my own map API or simply use Google Maps API in my application. Google Maps API is an external service provided by Google, which we can use in our application. API can be free or paid. We have several API like News API, Weather API, ChatGPT API, Spotify API, and many more. They all works in real time, means all the information provided by API are live. Like consider I'm creating a news application where I'll use news API. So because of that, I'll get all the latest news in my app. Getting my point? Now there is something called as REST API. Let's understand it. So REST stands for Representational State Transfer. It's a part of API that basically has a set of HTTP-based protocols and principles that defines how system can communicate over the internet. They use HTTP methods or annotations like get, post, put, delete and many more. Out of which, we will mostly use get, post and query method. Get method is used to retrieve the data. Post method is used to send data to the server. Query method is used when we have to specify a particular parameter. We will use all of this when we will create project. Okay? I know theory might sound very boring to you, but these are few important terms that you need to know before creating an example project. Next is JSON. JSON stands for JavaScript Object Notation. It is basically a format in which the data is preserved. Data is in maybe all the latest news or weather updates. Got it? But code cannot understand JSON format. Hence, we are supposed to convert it, or in technical language, we say parse the data or serialize or deserialize it. There are many ways to convert JSON format to data, out of which we will be using JSON library. I repeat, JSON, not JSON. We will add JSON dependency in Android Studio that will help us to convert it. Got it? That converted data will be our Fojo class, that is plain old Java object, or simply you can say a data class. Now let's have a look at API. As I am creating an example project only, hence I'll be using a fake API. We will use real API as well in the end of this series, but for now this is a popular website jsonplaceholder.typingcode.com that students and developers use to learn API. Let's go to this website first. Here it is. This is not API, this is a website that is providing us an API. Then where is API? These are all the APIs that website is providing us. Post, comments, album, to-do. Let's have a look at them. Now, out of all of them, I'll be going for albums API. Album as in song albums. Let's have a detailed look at it. Here, two things you need to know. First is the URL and second is JSON syntax. This is our URL. Till here, it's a base URL. And this one is our endpoint. That is basically our API itself. See, JSON placeholder is our main or base URL that provide us an API, and this albums is our endpoint, that is an API itself. Got it? This is important because in code we have to mention base URL and endpoint to access the service. Also, we can further customize URL as well by categorizing it more, but for now just remember this pattern. Then this is what JSON formats look alike. I know it looks confusing, but you will be able to understand it once you are aware with the JSON syntax. So let's have a look at it. Also, you will be wondering what is this language? So it's Latin, it won't bother us, okay? So now see, this is what the syntax looks like. We have two square brackets in the start and in the end. Those square brackets is array, okay? And inside array, we currently have two objects in it. Object is determined by the curly braces. So this is one object and this is another object. Both of them are separated using a comma. Then in each object, we have a key and a value separated by a colon. Both of them are in double quotes. This is key and this is value. For example, this is an array, inside it two objects, and then inside each object we have key and values. This ID is a key and 1 is an int value. Then this name is a key and Android is a string value. Then in second object, ID is the key and 2 is an int value. And name is a key and knowledge is a string value. Got it? There can be multiple key and values in an object and multiple objects in an array. Got it? Now let's have a look at JSON format. See, this square bracket is an array that starts here and ends here. In between, they have multiple objects. To be precise, they have 100 objects separated by comma. And in each object, we have keys and values. So in first object, we have key as user ID and value as 1. Then another key as ID and value as 1. Then another key as title and value as some string. Next, we have another object with same case but different values, and so on. So basically, we are going to send a request through Retrofit to this API or server, and as a response, it will send us this JSON response, which will convert it in data using JSON library and display it on the text view. Simple, right? Let's quickly have a look at all the steps. So first, we will add dependency, then permissions, then we will create a data class, an interface, and Retrofit instance. Then from all the above steps, we have sent the request, and now we will receive it and display it in the text view. Now let's go to Android Studio and create it. Choose MVVM's activity, name it as Learn Retrofit, and finish. First, as I said, we will add dependency. So go to Gradle module. These are the 3 dependency. I'll mention them in the description box. This is for Retrofit, this is for JSON library for conversion, and this one is for LiveData. We will use LiveData to receive the request. I have already explained LiveData in detail in one of my previous videos. You can click on the I button to watch. Then add view binding as well. Also, I do face error with Combine SDK, so I'll change it to 34. And now click on Sync Now. And done. Then next, as all of this process is happening on internet, so obviously we will require internet and network permissions. So go to Android Manifest. First, I'll add internet permission. Then next, I'll add access network state permission. And then next, I'll add access Wi-Fi state permission. And that's it. Now we need to create a data class. So right click on it, new class, name it as album item, and choose data class. Here we are supposed to add keys with their data type that were present in objects in JSON. I'll keep it side by side. See, keys are user ID, ID, and title, right? So I'll write here as well ID as int, then user ID as int, and then title as string. Simple. Then I'll add a serialized name to each one of them. Now what is serialized name? The serialized name is an annotation in JSON which is used to map a JSON key to a data field during serialization or deserialization. Basically, it allows you to specify a custom name for the key if it differs from the data field name to ensure a proper conversion between JSON and data. Safe play. Then we have keys. Values, we will receive it from server, but if you'll have a look at it, you will see all these objects are in an array. So we are supposed to create that array too, right? So come back to Android Studio, right click on it, create a new Kotlin class, name it as albums. As I said, we have to create an array list and inside it the object. So I'll extend it as array list and inside it our data class, that is album item itself, right? And that's it. Now our next step is to create an interface. So right click on it, create a new class, name it as album service and choose interface. Here we are supposed to define endpoint using HTTPS method, that is get method. So I'll write here as get annotation and inside it write the endpoint. Remember I told you about the base URL and endpoint? This is our endpoint. So I'll write here as /albums. Basically, get method retrieves the data, right? So to retrieve it, I'll create a get albums function. And as we are retrieving it, we will use response class. It's a part of Retrofit. And inside it, album class, it retrieves a list of albums. Simple, right? Now next step is to set up Retrofit instance. It is very easy. It's all mostly syntax only. So right click on it, create a new class, name it as Retrofit instance. Here we are supposed to define the base URL and initiate Retrofit. So to do that, first I'll create a companion object. Companion object consists of singleton object, basically like a static keywords. Then inside it, create a variable named as main URL and insert here the base URL, that is the website that is providing the API. I'll copy paste it. And done. Then below it, we will create a get retrofit instance function that will return a retrofit. So first, let me quickly write it. And done. See, it will return retrofit with its base URL as the URL we have mentioned above, and then JSON converter that will convert the JSON into data, and finally build it. Once everything is set up, we will receive the request through LiveData and display it in the text view. So first, we need to give a text view an ID. And let's go to activity main. Here add ID as title text view, because we will receive entire data but we will display only the title for now. I'll remove it and done. Then go to main activity. Here, as I said, we will receive the request through LiveData. So let's create it. First, let's set up binding. And done. Then next we need to initialize the service. So let me quickly write it first. And done. This line creates an instance of an interface that is album service using Retrofit. Basically, it enables you to make HTTP requests to the /albums, that is our endpoint defined in the interface. Then next, with the help of LiveData, we will take the response. So let me quickly write it. And done. Now see, this code defines a LiveData, that is response LiveData, that emits the response from the retrofit service.getAlbums. Emits as in sends the response. It is typically used for observing and handling the responses. Then next, we need to observe that data. So first, let me quickly write it. and done. See, this code observes the response live data, and upon receiving a response, it reads through the list of albums in the response body and store it in the album list variable. Then, if the album list is not null, means it is present, then use while loop to iterate through each album and store it in album item variable. And then for each album, it extracts the title and store it in album title variable. And then finally appends it to the title text view. Append as in to add. We usually use append instead of .text in web services. Okay? And that's it. Our code is ready. Let's run the app. Perfect. All the album titles are displayed on the screen. See, compare it side by side. I know it looks messy, but it's an example project just to make you understand how Retrofit works. Further, in upcoming videos, we will create a professional app using Retrofit, but for now, just remember the steps to implement Retrofit, okay? Hey everyone, welcome back to my channel. In this video, we will learn about dependency injection using Dagger-Hilt. The topic is kind of tricky, but don't worry, I'll try to make it as simple as I can. Also, dependency injection is a very vast topic, so one video is not enough for it. Hence, in this video, I'll only cover the basics of it. Later, in some other video, we will go in detail about it, okay? Now, let's understand what exactly dependency injection is. So, consider a code where we have multiple classes dependent on one class, which makes the entire code tightly coupled. Tightly coupled means classes are dependent on each other, and ultimately it becomes very difficult to manage and test. Hence, to overcome this issue, dependency injection was introduced. As the definition says, that allows the separation of object creation from their usage by making code more modular and testable. Means it makes the entire project loosely coupled and removes the dependency from the code. Also, as the last line says, by providing required dependency to classes from external sources rather than having to create their own. Here, external sources means using Dagger. Next, this is a general diagram where we have class A and class B. Here, class A depends on class B, which makes the class B as dependent of class A. Okay? As I previously said, there will be multiple classes depending on one class. Here for the general example, I have only one class depending on another class, but there could be multiple classes like class B, class C, class D depending on class A. Got it? Now next, in dependency injection, we have two types. Manual dependency injection, DI means dependency injection, okay? And automatic DI. Let's have a detailed look at them. So in manual DI, we create the object manually without using any external resource. Although it is not recommended to use manual DI because we have a better and advanced option available, that is automatic DI, which we will see in upcoming slides. But first, let's see what are the types of manual DI. We have two types in it, constructor injection and field injection. So in constructor injection, we pass the dependency of a class to its constructor. Simple. Then in field injection, dependencies are instantiated after the class is created. We will cover both of them practically as well, so wait for it. But for now, let's have a look at automatic DI. So in automatic dependency injection, we have two types, Dagger and Hilt. Basically, in automatic, we don't have to create each object for every class. Instead, Dagger or Hilt will make it for us. And that's what automatic means, right? Hence, it is highly recommended to use. Now let's have a look at each one of them in detail. So first, what exactly is Dagger? I kept the definition very simple to understand. So it says, manual dependency injection can be problematic depending on the size of your project. Obviously, see, means having 3 to 5 classes depending on one class, that is fine to handle, right? But there will be project where we will have 100 of classes depending on one class. Now that is difficult to handle, right? And that's when Dagger comes into the picture. So basically, Dagger generates the same code what we would have manually written. But here comes the twist, that it internally creates a graph of objects that it can refer to provide an instance of a class. Basically, it generates a factory type class that I'll show you when we will create the example project, okay? Now, all of this is done using annotations. Let's have a look at them. Module is used on a class that construct object and provide dependencies. provides is used on a method in the module class that will return the object. Inject is used on field, constructor or method to indicate that dependency are requested. Component is used on a component interface which acts as a bridge between module and inject. Singleton is used to indicate only a single instance of dependency object is created. And that's it. Then next is Hilt. Again, it makes the manual dependency injection easy to use by reducing boilerplate code. Basically, Hilt provides container for every class and manages their lifecycle automatically. So we usually use Dagger and Hilt together, but for now, not to make the project very complicated, I'll be using Dagger only. But later in upcoming video, we will cover Hilt as well. Now let's have a look at an example project. So this is what a project representation looks like. We have one class C and two classes, that is class A and class B. So class C depends on class A and class B, which makes them dependent of class C. Basically, every time we want to access class A and class B, we need to create an instance of class A and B in class C. That makes it tightly coupled, right? Hence, we will be using Dagger to remove the dependency. I have divided the project in 4 cases. In first case, we will write the code without any use of dependency injection. Then in second case, we will write the code using manual field injection. Then in the third case, we will write the code using manual constructor injection. And then in the fourth case, we will write the code using Dagger. Got it? Let's go to Android Studio and create it. So first, let me quickly create the 3 classes. That is class A, class B, and class C. And done. Now in class A, it's an example project, so I'll be simply printing a line in logcat. Nothing complicated, right? So here first I'll create a function named as start class A. And inside it, log as tag and message as class A started. And that's it. Similarly, I'll do it in class B as well. Function start class B and inside it log as tag and message as class B started. And that's it. As I previously said, class A and class B are dependent of class C. So go to class C and this is where we will create an instance of both of them. First case, without using dependency injection. So inside class C, I'll call class A and class B. And done. Then we will create a function as start class C and inside it I'll create an instance of class A dot start class method and class B dot start class B method. Then write a log for class C started. And that's it. See, class A is independent, class B is independent, but class C depends on class A and B, right? Then lastly, call class C in main. So go to main activity. I will here call class C. Then create an instance of it as class C dot start class C, and that's it. This is what the code looks like without dependency injection. I know you will be wondering, it looks so easy, nothing complicated, but think as a professional developer. Then you will realize this is all tightly coupled, which makes your code very difficult to manage and test. Probably not in this case because there is only 3 classes. But imagine a project with 100 or even thousands of classes. That's where all these advanced topics are used. I'll show you the output. See, in logcat, we have tag as class A started, class B started, and class C started. That is very basic. I'm not going to show output in every case because it literally is same. What important is our code because that is different in every case. Now let's move to our second case using manual field injection. Class A and class B will be as it is. Only class C and main will change. So let me quickly comment all the previous code and done. Now see here. As the field injection says, dependency are instantiated after the class is created. Hence, instead of making instances private, here I'll be using late init. So let me quickly write it. And done. Late init modifier declares a property without initializing them immediately. And we will initialize them, but not here in main. Okay? And that's what field is, right? Then where means the value can change later. And then similarly from the previous code, we will write start class C function as it is. And done. Then go to main activity. Here I'll call class C instance. And then as we have used late init in class A and class B, so we need to initialize them over here. Hence I'll write here as class C dot class A is equal to class A object. Similarly for class B as well. And then once it is initialized, then start class C method. And done. This is what manual field injection looks like. It is not tightly coupled, but still there is a lot of code to write. Hence, it is not recommended to use. Next, let's have a look at third case, that is manual constructor injection. I'll comment the previous code. And done. Now in constructor, we usually have parameters assigned. So class C is a constructor and inside it I'll write private val class A as class A and then private val class B as class B. Both of them are our constructor parameters. Then we will write start class C function as it is. And done. Now come to main activity. Here I'll call both the classes instance, class A and class B. Then I'll call class C instance as well. But as class C is a constructor, so obviously it will require its parameters as well. So I'll mention here as class A and class B as its parameter. Then simply call start class C method on class C instance. And that's it. This is what our manual constructor injection looks like. Easy, right? But there is something more easy than that, which is Dagger. So now let's move to our fourth case, that is using Dagger. This is very important, so focus. As we are using Dagger, so obviously we will require dependency. So go to Gradle module. Here add both the dependency. I'll mention them in the description box. Also, as we are using KPT, so we will require kept plugin as well. So inside plugins, mention the KPT plugin. Then next I'll change compile SDK to 34 and that's it. Now click on sync now. And done. Then go to class A. Here we will add inject annotation with a constructor. Remember I said inject can be used with field, constructor and method. So that's why we'll be using here constructor. So wherever we mention inject annotation, it requests for its dependency. Like I have mentioned inject for class A, so it will provide us with class A dependency. Likewise, we will do it for class B as well. Here I'll add inject annotation with a constructor and done. Then go to class C. Here also I'll mention inject annotation with a constructor. As it's a class where all the other classes are dependent, so we do have parameters inside it. Then write start class C function as it is. And that's it. Now listen to me carefully. To use Dagger, we need to create a module object and a component interface that we will access in main. So first let's create module object. Right click on it. New class. Name it as class AB module. And choose object. I'll mention module annotation here. Let's have a look at its definition. So module annotation is used on class that construct object and provide dependencies. In our case, it is class A and class B, right? Then inside it, we will create two functions that will return the object. And to do that, we need to mention provide annotation, right? Let's have a look at its definition. It says, provides is used on a method in the module class that will return the object. And that's what we are implementing, right? So I'll mention provides annotation and then create a function called as provide class A by calling class A that will return class A. And that's it. Similarly, I'll do it for class B as well. And done. Our module object class is ready. Next, we need to create component interface. We create component interface for the class on which every other class is dependent on. So in our case, it is class C, right? Right click on it, create a new class. Name it as class C component. And choose interface. Here we will mention component annotation. Let's have a look at its definition. It says component annotation is used on a component interface which acts as a bridge between module and inject. We have already used inject in every class, and also we have already created a module object for those injected class, right? So let's mention it here. Modules as class AB module. And done. Next, inside the interface, create a function as get class C instance. That will call the class C. And that's it. Now our component interface is also ready. Then go to main activity. Rebuild the project. And done. Remember in start I mentioned about some factory type class which Dagger uses? I'll show you that. See here, a new directory is created called as Java generated. In this directory, we have all the factory type of classes. Basically, factory classes are used to create instance of objects. All of them are generated by Dagger. Let's have a look at them. You are not supposed to modify or edit it, okay? Now here, write Dagger See, the component interface will create its own Dagger component. The Dagger prefix followed by a component interface name is a common convention for Dagger generated components. Then dot create method and then dot get class C instance, which will obtain the instance of class C, and then dot start class C method, which will start its functionality, which in our case including starting class A and class B as well. And that's it. Our code is ready. Now let's run the app. The output will be same only. See, class A, B, C started. That's not even the concern. Our concern is writing code using Dagger. I know Dagger may seem complex at first, but its advantage become more apparent as your project grows and evolves. The benefits of improved code organization, maintainability and testability often outweigh the initial setup. Like you will be wondering, why is there a need of module object, then component interface and all? It's all extra code. No, they are not. They are all your initial setup so that later your code becomes easy to test and manage. It's like working hard in your 20s to live a stable life in your 30s. Also, I'll be releasing this video in Hindi as well on my second channel, so please do subscribe it. And for more updates, you can follow us on Instagram or join a Telegram group, link in the description box. So yeah, that is it for the video. If you are new to this channel, then please consider subscribing to my channel and I'll see you in the next video.